Hello class, today we're going to be talking about domain of functions. So let's recall what domain is. A domain are all the possible x values of a function. This has popped up in Algebra 1-2 and Algebra 3-4, and well, here it is again. And we'll be dealing with it throughout the course. So all the possible x values of a function. So remember that when we're talking about x values, we're talking about from left to right. Right? Where does the function exist going from left to right? What are the possible x values I can plug in and it would still make sense? Well, here's the idea. The domain of functions are generally from negative infinity to positive infinity, meaning all the numbers, with some exceptions. And I just listed three. There are some more, but so some of the bigger ones. We can't have negative in the square root. Remember, we can't have a negative under square root. That goes into imaginary numbers. And then we can't divide by 0. That comes into play in rationals, which we'll talk about in a second. Also, can't plug in negatives into a logarithm. That's just kind of a thing. But we're going to focus mostly on, well, actually, we're just going to focus all on these two today. So you can't have a negative under a square root. So let's think about the most basic function, or the most basic square root function. And that is this. And I want to know, what is the domain of my function? That's what the D stands for. Well, what number can I plug in for x where we'll get 0? And, well, that would actually be 0, right? It's a pretty easy function. Whatever you plug in is what you get. So does it make sense that I can't plug in negative numbers here? Like I can't plug in -4 because then that will be a negative under a square root, or I can't plug in -1. That'll give me a negative. But I can plug in 0. And I can plug in positive numbers. I could plug in 1. I could plug in 5. I could plug in 5 million if I wanted to. And that would be okay. So what numbers can I plug in for x? Well, that's the domain. That's what the domain is telling me. Well, I know that I can plug in 0, and I know I can't plug in anything to the left of 0. So my left bound is 0. Actually, I have to be more specific. I can plug in 0, right? So that's going to be a bracket. And 0 to, I can plug in any large number, right? 0 to infinity. And if you're wondering, whenever we have infinity, we never use brackets. We always just use the parentheses, okay? Let's talk about another one here. Let's say that I have f of x is equal to 2x minus 4. And I want to know what numbers can I plug in so that I'll still get positive values or 0, right? I don't want to plug in numbers that'll give me a negative here. Well, all you need to do is take what you have under the radical, and I want to know when it equals 0, right? So I'm going to set it equal to 0 and solve for x. 2x minus 4 equals 0. And that'll tell me what x value I can plug in to where it gives me 0. So just some algebra here. We add the 4 to both sides. That'll give us 2x is equal to 4. And then divide both sides by 2. A little bit. And that will give me x is equal to 4 divided by 2, which is 2. So notice if I plug in 2, 2 times 2 is 4. 4 minus 4, that gives me 0 here. So what this is saying is I can't plug in any numbers less than 2. Let's try plugging in 1. See what happens. 1 times 2 is 2. 2 minus 4 is -2. So I can't plug in a 1 there. So what is my domain in this function? Well, in this case, what was the number that I plugged in 0, or I plugged in, it'll give me 0? 2. And I can plug in 2, that's why I have my bracket. And can I plug in insanely large numbers? Let's see. Let's see if I plug in 8 or something. 8 times 2 is 16, minus 4 is 12. Okay, that's still positive. I could plug in 100. 100 times 2 is 200, minus 4 is 196. That's still positive. So you get the idea. From 2 to infinity is my domain in this case. And again, whenever you have infinity or negative infinity, always use the parentheses. So that's how we determine the domain of square roots. If you have something more confusing than this, which you probably will, just set it equal to 0, solve for your x, and that'll give you your left bound. Or right bound if it's negative, but we won't get into that. It'll just be your left bound for now. So let's move on to our other rule. Can't divide by 0, or dealing with rationals. So a rational function is any function where we have an x, or a polynomial divided by another polynomial. So we're going to have an x on the top, and we're going to have an x on the bottom. So there's going to be a rule here, right, that says we can't divide by 0. That's something we can't do. So what number can't we plug in here? Well, we immediately see right away x cannot equal 0. Because if I do plug in 0, we get, well, 3 over 0, and we can't do that. But we will take the rule that says the domain of the function is generally from negative infinity to positive infinity. So with rationals, the domain will look like this. We will have something like, well, we know that that we can plug in any number except 0 here, because we'll get 0 in the denominator. So we know that we can plug in from negative infinity to 0, and we can't plug in 0. So I'm going to keep a parenthesis here. And then I'm going to draw, it's kind of like a U. It's for a union. It just shows that there's a gap in between, okay? And then we go back, and it's from 0 to positive infinity. So this is saying that I can plug in any number except 0. Okay? So you're going to want to write your domain just like this. Now, what if we had something a little different here? What if I had something like g of x is equal to x plus 3 divided by 2x minus 4? Well, it's not immediately obvious what number we can plug in for x that'll give us 0 in the denominator. Some of you might be able to do it right away, but I don't know. Sometimes for me it gets a little confusing. So again, what you're going to want to do is take the denominator and set it equal to 0 to figure out what value it'll get what x value you can plug in that'll give you 0. So 2x minus 4 equals 0. Just some algebra here. Add 4 to both sides. We get 2x is equal to 4. And then divide both sides by 2. So that'll give us x equals 2. So notice if I plug in 2, 2 times 2 is 4, minus 4 is 0. That is my problem number right there. That is the number I can't plug in, because it'll give me a 0 in the denominator. So the domain, in this case, exists from negative infinity to 2, and I can't plug in 2, so I'm going to keep my parenthesis there, and that's not going to be a bracket. Then union 2 to positive infinity, because there are no other holes where I would get a 0 in the denominator. It's just that value at 2. So let's go over one more, just so we kind of have this down. Okay, h of x is equal to x minus 2, x minus 3. So again, we want to know what value that we plug in x, or that we plug in for x, gives us a 0 in the denominator. In this case, you can probably see it's just 3. 3 minus 3 is going to give me 0. So x can't equal 3, right? So our domain is going to be from negative infinity to 3. Sorry, that's supposed to be a 3. That's a funny looking 3. From negative infinity to 3, union 3 to positive infinity. Okay, so that's just how we do that. Get started on your worksheet. Let me know if you have any questions, and have a good day.